We'll start with a demo of QML just as it comes when you first install. If you go down here, you see the test console installation directory and click demo, and you get offered three types of demo: the TSC, the Synoptics, and QML. And QML is the new one that we're interested in today, so I'll click that one, and up pops this little sort of demo presentation. And really these are just a few toys to show what QML is capable of. Everything that you see in here is completely scripted. Each of the pages is perhaps 50 to 100 lines of script, and the overall presentation is itself a script which loads the underlying scripts as well. And I'll click just through the demos. First of all, you can see there's a 3D presentation. It's a floating teapot, just to demonstrate that 3D views are possible. I'll click through to this one, and this one is showing actually a shader, and you can script shaders in QML. So the shader program is written directly to speak to your OpenGL graphics card, and those scripts can be written directly in QML scripts. And here's just to show that QML scripts can also be interacted with, and this one is combining user interaction with a shader. Oops, there we go. And there's another shader-based one which is taking the Thermo logo and making it look slightly seasick. Now, in these presentations you also get standard swipe movements. And I'll go back to this first one because it demonstrates some of the interesting things about the QML architecture. What you see here is a model view presentation, and it's quite a highly adapted one. This one is actually a path view of the planets, and what you can see is as the planets move away from us, the current selected planet is the one here. As they move away from us, they decrease in size, and we just click on one or other of these planets, and one of them gets selected. And one of the things that we can demonstrate here is that as we select one planet, some of its attributes from the underlying planet model get updated here. So in this case, it's Mercury, its name, its mass, its orbit. And what this demonstrates is that the bindings can be both static, for example the mass, and they can also be calculated. This one is actually calculated. And you'll also see that we can do things like control the visibility. If the number of named moons is more than 0, then this piece of text here becomes visible. So you'll find out there that actually Jupiter has 63 moons. And obviously this type of view was intended for things like album browsers that you might see on media players, but it's quite a nice way of demonstrating how QML deals with repeated data and arbitrary underlying data models, and the separation of the model, the view, and the individual delegate for each item that you might select. Well, having just seen some demonstrations of floating teapots, I thought it might be nice to see something a bit more oriented towards space applications. And also what I'm doing here is demonstrating that the user can open his own arbitrary QML files that he prepared himself. So I've got one here that I got from SketchUp, and I downloaded it from the SketchUp warehouse. Now it's called the Trimble warehouse. And this one is actually the Cassini spacecraft, which is a fairly intricate one. It's not enormous, but it is quite intricate. And one of the things this is intended to prove that we don't have to deal with monstrous great tools such as the ones that are used for mechanical engineering. We can just use graphical tools that are fairly easy to use. And this makes use of 3D models a good deal more feasible than it has been in the past. So you can browse in and see a certain level of detail on the Cassini spacecraft there. I'll close that one, and I have another one here which demonstrates that 3D models can be joined into joint objects and individually animated. And I believe this one is called Sat View. Let me see. There it is. And in this one I've taken my Cassini model and placed it in orbit around a sphere on which I have placed a texture that looks a little bit like the Saturn surface. And then I set the whole thing rotating at a slow speed. And typically with OpenGL, you do still have to deal with issues like what is the field of view, what is the position of your eye, where is the lighting. There's no magic here, you do still have to think about these things. But nevertheless, QML does make it relatively easy. I'd like to show you something which is a little bit more related to real monitoring control applications, and that's an alphanumeric display viewer. It looks a little bit like the SCOS 2000 AND viewer. Before we start, I'm going to load a database, because this is a system where databases can be loaded and unloaded on the fly. And there it goes. And there's the new display. In fact, I could open any number of these displays. There you go. But to keep things clear, I'm just going to open one. The display is a little bit more dynamic than you might have seen in the past. It sort of dynamically resizes and fills up the display appropriately. And to show a little sort of added value compared with what we used to have in the past, it doesn't just show alphanumeric displays, or displays as they're defined in the databases they used to be, but it also allows to present the same type of information when it's organized into groups, like that. And it's also possible to manage test sequences, and this is basically a list of all the test sequences I currently have defined. And we are also able to load user-defined QML scripts, which here are called quicks, and quick is just a term used by Qt for QML files. And here's, for example, another toy demonstration of, I suppose, a game of patience showing animations, and that's just one that's sitting around. And I also have some simple examples. This one is to show a very, very basic first prototype of how to show a telemetry parameter and a couple of telemetry parameters, their state and their current raw value, and their description. And I also have there a little prototype of how to start a test sequence. But we'll come to those in a moment. Just moving on here, we have the possibility to manage test sequences. Now, I have here a very simple demonstration of how to show how test sequences can be monitored as they change their state. And I've just started that one by double-clicking it, and it's actually running through in an artificial way. It's running through a few of the different possible states that a test sequence can be in, and it's then just to demonstrate to you how you would see the test sequence changing state in this MMI. And as you can see, what it's done is it's actually suspended itself and given me a message to say now resume. And the way I've programmed this is actually just to have double clicks as when there's an obvious action that you could do on the test sequence, is to just double click. And now it's gone back into running. And what it's done now is it's deliberately generated a resumable error, and it's actually tried to send a non-existent telecommand when it's not even connected to sending anything. So it's come up with a message saying not connected, and it's in error. And in this case I can actually resume it, as you can see down there. And I'll double click it and off it goes again. And in this, next it's going to a prompting state where it's actually asking us a question, and it's asking us a question, finish the loop. And to avoid that you get too bored, I'm actually going to answer that prompt with the answer yes, please do finish the loop. And out it goes off out of the loop, and it says it's about to have a non-resumable error. It's counting down, and then it's made an invalid command call to a procedure called terminate me, which is a hint that if I really want to terminate this, I should terminate it now. And the convention I've used to terminate a script is actually to press and hold, and there you go, I've terminated it. And you can basically see that I could repeat that. Where is it? Demo state changes. There we go. I could just repeat that, and at any time I can terminate it again. And it's just a very simple way to control test sequences. Now, of course, I quickly showed you some of these displays, and of course there's no telemetry there to display, so it looks a bit boring. So what I'm going to do is start a test sequence that I know will generate some kind of telemetry and some state changes, so there's something to see. So what I'm going to do is run this test sequence, which is telemetry monitoring, and off it goes. And this test sequence actually has its own MMI. It's actually designed for testing telemetry monitoring features, but it has a side benefit in that it will also generate, it's quite useful for demos and generate something to see. So I'll leave that running, and then we can go back to the displays and have a look in this one. And at the moment it's actually, I can see from the test log that it's actually testing stuff that's inhibited, and it'll run through that. It'll take a while to run through that, so I might as well talk. What you see here is actually a view of an underlying model. The underlying model is a mixture of both dynamic and static data. The dynamic data is obviously the states of the different parameters, and the static data is the database definition. And in fact, we're showing stuff that is a little bit of a mixture. So when I click on these different parameters, I can actually see a mixture of its current state, like at the moment they're invalid and have no values. There we go, we're starting to see some real telemetry. And then there's also some mixed static and dynamic data. So for example, here we see the limits that are defined for this parameter. In fact, there's 16 limits on this one. I can scroll through them there. And there's 4 possible curves on this parameter. Now those curves and limits are actually dynamically selectable. So what's going on is that as limits are hit or as curves are selected, you see the different curve or limit highlighted. And that should be pretty familiar from what you've seen in previous systems. If you refer back to my previous demo where I was showing you a path view of the planets, what this MMI is basically demonstrating is that you have, for example, grid views. These things are all grids. They lay out data according to a grid. And the delegates within those views are mostly these square boxes, because I've chosen to emulate the Windows 8 user interface or at least emulate it to look at home on Windows 8. And so we have a different, what this demonstrates is that within those grids we have different types of delegate. Here we've got delegates which are the delegates for viewing the particular state of a given parameter, and there we have delegates for a group, and there we have delegates for a test sequence. Let's carry on watching it. And we should see in a little while this one changing state, yeah, and this one changing state. You notice that the limit is selected there. It's highlighted in red because it's an alarm limit. There you see there's a delta limit because it changed by too much from one TM sample to another. And obviously what I've chosen here is something that looks a little bit like it might fit within Windows 8. In fact, my choice was more related to emulating the Windows Phone user interface rather than Windows 8 specifically. I chose that for different reasons. One is, of course, it's a lot easier to emulate something where you don't have to design all the aesthetic appearance yourself. Another consideration was, in fact, that this system is quite likely to have to appear at home on Windows 8. That's the most likely operating system that's going to be used in the near future. And of course, I actually happen to quite like their user interface. It's fairly conservative. It's not too full of ridiculous animation gimmicks, and so animations that are so elaborate that they get irritating after a while of using it. And but nevertheless, we get this sort of ability to slide around. See, there's a group view of the same type of information. And one of the nice things we can do with this system is we can also define new displays. So what I'm going to do here is create a new display, and then edit its test me. This is a test, and then I'm going to drag and drop some TM parameters that I can see here, and I could drag them one at a time, or I could also drag them as groups. So I just drag that as the whole group, and now I've on the fly created a new display. And just to prove that you can see that display online, I'm going to call up MIB view, and as everybody knows, the SCOS 2000 display definitions are stored in the DPF table, and there you'll see that new display definition, test me, this is a test, and down here you'll see those are actually, there's my test me display, and that's the list of parameters that's in there. I'm not at all limited to only having 64 parameters. You can have as many as you like. In fact, I think I have an example here with more than 1,000 in it. And one of the things I can now do, it's already defined in the database, but one of the things I can now do is save that database back to, it actually saves the data back to a specific user path, so that if I want to use my own displays in future, it'll automatically load my displays as opposed to the ones that are in the system. And later on, if I want to make those displays official, then I can merge those. Then I can merge those displays with. Then I can merge those displays with the official database. One final thing that I'd like to say is that this user interface implementation is written entirely within one script, and there's nothing special here that we're doing that you can't do yourself, and everything that you've seen here is using interfaces that are documented. And although this particular implementation happens to be compiled into our system so that we can deliver it easily, it is possible for you to configure that this alphanumeric display toolbar starts up your interface instead of ours. So that would mean that you could configure this to use a different look and feel from the one we've chosen here, or so you're not stuck with something that looks like a little bit like Windows 8. Or you can make it very mission specific, so you can have pictures dedicated entirely to your spacecraft, or you can adapt it to your own corporate look and feel. So the intention is to be to extend this flexibility as far as possible to the end user.